2.6, modeling contextual situations. You've heard me talk about contextual situations before. When you are thinking about the context behind a problem, you're thinking about the story that comes along with it. So this is actually a really good example. As part of your college program, you are a summer intern in a law office, and the office manager asks you to gather information about leasing a copy machine for the office. The sales rep at Eastern Supply Company recommends a 50 copy per minute copier to satisfy the office's copying needs. The copier leases for $300 a month, and there's 1.5 cents a copy. Maintenance fees are covered in the monthly charge, and the lawyers would own the copier after 39 months. Some of this information is probably a little bit extra and excessive, but for the most part, everything that we need is here. The total monthly cost depends on the number of copies made. They've even kind of done a lot of the work for us here. They want us to identify the input and output variables. Since they just told us that the monthly cost depends on the number of copies made, we know now that the output variable is the cost, or we can say monthly cost if we want to get extremely specific. And the input variable, it depends on how many copies are made, so we're going to say that the input variable is the number of copies. Write a statement in words to determine the total monthly cost in terms of the number of copies made during the month. Okay, so this is all of the information that we've seen up here in lots of different ways. Let's see here. The copier leases for $300 a month, and then there's 1.5 cents a copy. So I'm going to go ahead and start off with y equals. I guess I should probably have, there we go. Y equals $300 we're spending no matter what, plus 1.5 cents per copy. Some of you might have written this in a way where you had something like 1.5 times X. But if you read this, this is $300 plus $1.50 a copy. We have two different units of measure here. We have dollars and we have cents, and we can't use two different units of measure in one sentence. So we're going to have to change how we write this to make sure that everything is written in terms of dollars. So how do we write 1.5 cents in dollars? You're going to have to go ahead and change that so it looks like this, 0.015. So over here I'm going to write 0.015. That's 1.5 cents in dollars units, and I'm going to put an X right next to it. There is our formula, which is kind of tricky. That was really tricky, actually. But that's kind of why this is a good example, because that's a little bit tricky. Ooh, goodness. All right, well, that's interesting. Okay, so we have to complete the following table. We want to know how much the monthly cost is dependent upon these four numbers, four different bunches of copies. So go ahead, you can use your calculator, you can use the table function if you want to, but you're going to use this formula to fill out these four boxes, and then you can pause it and then fill those in and then come back. Hopefully you got the following information. I actually put in my calculator the first two values and realized that these kept going up by 5,000 copies, the example. And every time we went up by 5,000 copies, the cost went up by $75. So to get the last two values, I just added $75 to 450, and then I added it to 525. So this is what your table should look like. Translate the statement in part B into an equation. Let N represent the number of copies made during the month, and C represent the total monthly cost. We kind of already did that, but we can replace the variables with the numbers that they're asking us to use, or the numbers, I'm sorry, the letters. C equals 300 plus 0.015 times N. They also want us to use the result that's obtained, and they want us to use this formula to figure out how much it would be if we had 12,000 copies. So hopefully in your calculator, you would be replacing the input variable with the number 12,000 to get an answer. Hold on here. Let me just fix this because I miswrote it. The answer would be $480. My number has a unit of measure next to it, so whoever's looking at this would know that I know that I'm looking for something that is the cost measured in dollars. Is $12,000 a replacement value for the input or output variable? We inputted 12,000, so this would be a replacement for the input variable. I want you to flip to the next page in your notes for this section. We are going back to solving some equations by replacing one of the variables with a number. And these ones are a little bit more work than the last one, so I'm going to do the first one with you. If y equals 3x minus 5 and y is also equal to 10, we're going to plug 10 in for y, so our equation looks like this. Whenever I'm solving equations, especially if they have multiple steps, one thing that I like to do is I like to put a line where the equal sign is so that it reminds me that whatever I do on one side of the line, I have to do on the other side of the line. That is respecting the equal sign, really. It's kind of dorky, but it is. So I'm going to start off by canceling out my -5 by adding 5 to both sides. 10 and 5 are like terms, so I can combine those to get 15. 15 is equal to 3x, and I'm going to undo 3x by dividing both sides by 3, and so x is going to be 5. Go ahead and do B, C, and D. You're going to pause this, and I am going to go over these with you in just a moment. Pause it, and then try these, and then come back. So for B, I'm plugging in 24 for y. So I have 24 equals 30 minus 2x. Drawing my line. I need to cancel out the 30, so I'm going to subtract 30 from both sides. So I have -6 equals -2x. I'm going to divide both sides by -2. So x is going to be equal to +3. You can always check these in your calculator by plugging in 3 for x and evaluating that right-hand side to see if it's equal to 24, if you wanted to. For C, I'm going to plug in -9 for y. This is a good example because we've just been talking about if you have a fraction, you want to get rid of the fraction, it's all alone over there with a variable. I can multiply both sides by its denominator to cancel it out. So I have 3x equals -36, and I'm going to divide both sides by 3. X is -12. The last one, I'm plugging in -3 for y. I'm going to start by subtracting 15 from both sides. So I have -2x equals -18. And then dividing both sides by -2. X is going to be 9, +9. A negative over a negative is positive. Okay, so those being done, let's talk about this last example. Oh my goodness, I can't stand it being crooked. Oh, right there. It's still not straight. Oh my God, this is driving me nuts. I wish there was a button. Okay. It's not straight, but I don't care anymore. A U-Haul costs $20 for the day plus 79 cents a mile. You're going to write a symbolic rule to describe the cost of the U-Haul for 1 day rental. Identify the input and output variables. So there are two things going on here. One of them is cost. The other one is miles. One affects the other. So hopefully you're identifying the miles as the input because however many miles we drive affects the cost, so the cost is the output. If I use C to represent cost and M to represent miles, I'm going to write a symbolic rule starting off with C equals, cost equals, no matter what, I'm going to spend $20 plus 79 cents per mile. There is our equation. You probably already did something like this if you answered the bonus question that is due by class today, which obviously we don't have class today, but and this is for the section that I'm teaching right now. It might not be a bonus question for all the other sections. Bless you. Okay, so this is the end of this section, and so I am going to close out this video, and we will start a new one for the next section.